We'll proceed in pseudo calculus problems. Pseudo calculus problems, why we will give more emphasis into it because pseudo 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 calculus problems. This problem, this problem and solution, they will finally extend to artificial intelligence and machine learning. So in artificial intelligence and machine learning, where there is dependency and there is algebra, then there the calculus will come. Calculus means where there is dependency and there is algebra, then calculus would come. So calculus is inevitable that it will enter into artificial intelligence and it will be very complex because there are too many coordinates there, too many features are there. Each feature is one coordinate. If I have 10 features, then it is 10 coordinate system. We know only 3 coordinate system x, y and z. Okay, 10 coordinate system, 100 coordinate system, 1000, 10,000 coordinate system. So that is difficult to proceed upon. So what is the solution? Solution is that everyone has to understand the basics of calculus, the how calculus start and how I can start solving a problem and later I would mold it into calculus. So how I can start solving a problem and then slowly I would mold it into calculus. So that is the scenario. So we are in discussion. We are in discussion for changing for calculating the perimeter of a circle. This is a circle. If this is a circle, then it has perimeter. This is perimeter of a circle. What is the length of the perimeter? That is under question mark. If this is a circle and this is perimeter of a circle, what is the length of this perimeter? We have seen that we can calculate the length in a way. I'll take a small strip here and calculate its length. Then I'm sorry, if this is a circle, I will divide this circle into small strips. Okay, I'll divide this circle into small strip. Consider I am dividing this circle perimeter into n strip where n tends to infinity. This one strip is very small. What is the length of a strip? Ith strip. Consider this is x-axis. Consider this is x-axis. If this is x-axis, then this is y-axis. This is y-axis. This is x-axis. In that fashion, consider I take here and here. This strip I am taking, that is the ith strip, where I is 1 to n. So the first strip, this is x-axis, and if this is x-axis, then this is x-axis, then this is y. This is x-axis, then this is another radius. This strip is the first strip. If this is the first strip, then this is the second strip. If this is second strip, then this is the third strip. So all strip by strip. I am talking about any ith strip. What is the curvature of any ith strip? That is, if radius is r and angle between ith strip is theta I. Theta is the angle that spans from x-axis and it moves completely. This angle is theta. It starts from x-axis and it moves completely and goes full 360 degree. Okay, that is called Hup, hup, hup. This is this is radius and angle grows and angle go full 360 degree. Consider at any point I'm talking about this and this, not this. Any point I'm talking about a strip that is the ith strip. The ith strip, this is the section I'm talking. This is the ith section that starts from x equal x axis. Consider this angle is theta. I can say theta I because every strip angle is not same. But theta 1 plus theta 2 plus theta 3 plus theta n equal to 360 degree. That is for sure. Okay, consider this is theta I. Okay, ith theta. What is this length? This length is r theta. Okay, so ith theta length is r, which is constant for a circle. R theta ith theta theta bottom right small I. R into theta ith is the length of the parameter. That is the kind of length of the parameter for angle theta I. Now I will add for all I, and that will become perimeter. What is your perimeter? My perimeter is summation sign I equal to 1 to n, where n tends to infinity, r into theta I. R is constant. I can keep r outside. Now we have come to a kind of repeated addition of theta, even though all thetas are not same. Theta 1, theta 2, theta 3, theta 4, all may differ, but still, we can say that it is theta I. Okay, we can say that I equal to 1 to n theta I. If I keep adding all the theta, it will become 2 pi. Indeed, it is 2 pi. 2 pi r is the circumference of a circle. But if I'm making a repeated addition of a small section, okay, I may consider this is theta. This is theta axis and this is radius axis. Okay, in that fashion, radius is always constant. It will make a flat line, that is a radius. Theta will grow, and it is growing from origin to 2 pi. In that, I made a n section. N section I made, where ith section is theta. Ith section, the width is theta I. Theta I, theta I, theta I. If I add all the theta I up to n, it will become 2 pi. In that fashion, it becomes r. So I can now nicely convert summation I equal to 1. Repeated summation is more or less multiplication only. And multiplication is nothing but integration only. Means repeated summation, or I can say r into theta I. That is multiplication. Someone can consider like this. Otherwise, I can keep out r outside. It becomes summation I equal to 1 to n theta I, where theta 1, theta 2, theta 3. If this kind of summation is there, I can politely convert into d theta. D theta limit is from 0 to 2 pi. That is the net summation. So I can say now the parameter is r into integration 0 to 2 pi d theta. Okay, now consider that r is function of theta. R is not constant. Makes sense? Possible, right? R may be function of theta. If r is function of theta, if r okay, if r is function of theta, then what is the perimeter? That is the question. R can be anything. R can be cos theta. R equal to cos theta. What I'm trying to say, in theta r plane, if this is theta, and this is r plane, r equal to cos theta, means when theta is 0, r is 1. When theta is pi by 2, r is 0. When theta is pi, then r is minus 1. So r is varying with the theta. Can you show in xy plane? I can show in xy plane. Consider this is x-axis and this is y-axis. Now I have a radius and consider, okay, okay, I don't have another one. So consider this my hand is x-axis and this is y-axis. Okay, if this is okay, if this is x-axis and this is y-axis. Now this point is origin. From origin, I am taking one line like this. This is radius. Now angle with x-axis is theta. Now as theta is growing, radius is moving. But radius will not only move with the theta, radius will change its shape also. That is r equal to cos theta. When theta is 0, radius is 1. Means full 1 is there. But as theta start growing, radius will start shrinking. And one time will come, the radius will start from here. And when theta is 90 degree, radius will come to 0. Okay. Now here when 90 degree angle, when theta is moving, radius is shrinking, shrinking, shrinking. When theta is 90 degree, radius is 0. When theta grows beyond 90 degree, radius starts becoming negative. So radius theta is going beyond 90 degree. Now it is have crossed 90 degree, but this radius is negative. To make radius positive, we will draw the radius is exactly in reverse direction, 180 degree from here. So radius has come here. So from the 90 degree onwards, radius will start from here and then from 0. And again it will start growing and it will complete a circle. This is the circle equation r equal to cos theta, where left side this is origin, means r can vary with the angle. In that sense, can I calculate the perimeter of the circle with r theta as one section and adding all the sections? Certainly not. Anyone would say, no, try same thing. R radius into theta is the arc. Now take ith arc, divide the circle that is r equal to cos theta. This is not origin. Origin is here. This is x-axis and this is y-axis. Origin is here. That is r equal to cos theta. We have discussed it. This circle, if I take in xy coordinate, it comes as x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. This circle is of radius 1 by 2. Radius 1 by 2 and center is at 1 comma 0. Anyway, what is the perimeter of this circle? That is under question mark. If r is constant, then I can take any small arc here with angle theta. With angle theta is r theta. Now this is r theta, r theta, r theta, where theta is angle. If theta I say it is ith theta, then r theta I is the arc of any theta I angle anywhere. Okay, if that is the scenario, then net perimeter is r theta I, where r is constant. If r is varying with the theta, then if I take 2 points here, consider I take 1 point here, and this angle. This is very meticulous, very miniature. That's why this channel name is Miniature Ink. Meaning, okay, so this is very miniature. Miniature in the sense that if this is radius, then I'm moving this radius theta angle. If I'm moving this radius theta angle, now this is the theta angle. I move theta angle. I'm trying to find this arc length, but this radius is changing. Here, consider this is the radius at one point, okay, and or radius at one point. Now I am moving angle theta. Now radius instead of constant, radius started reducing when I move in theta, because radius is function of theta, and here radius is here. When I am taking at this location, radius is this big. When I started moving radius like this, the radius started, as I move, radius started shrinking. After theta, radius is here. I mean here, this much is the radius. So here this is the radius and here this is the radius. Radius is not constant. Now if I draw this line, then this is not the arc we are thinking of. So this cannot be r theta. For r theta as arc, both radius should be of same length and theta is angle between them. Then if I take this arc length will be r into theta. That is the arc. But in the theta, one side is like this and another side is like this, and it varied slowly, and this is the arc it is making. It will not be this arc into theta, not possible. So in the varying radius, when radius is function of theta, then any section, if I divide a circle into many sections, for the ith section, I cannot say that perimeter is r theta, r into theta I, because r is varying. So this concept of adding one by one all the section is all right, but not with this formula, that is r theta I. This is okay, but not with. I'm not saying that it is not okay. Even if r is a function over theta, and if I write r as function over theta, f theta into I, that is for ith section. If this calculation is perfect, then I can keep adding r function over theta, f theta I into theta I, summation of I equal to 1 to n. This will get converted into f theta d theta, the way we did in density function. Please watch our previous video. There along the x-axis density of an iron rod is changing, or force is changing along x-axis. What is the work done? Like there is a spring and it is kept at the origin. I stretch the spring to a location like this, and then I leave it. Okay, now the force that spring is showing is maximum at this point. When a spring is going to its original position, force is decreasing on the screen. The stretch is decreasing. At any x distance, force is function over x. Consider that is x. The way x is growing, force on the spring is growing. What is the work done by the force when it moves a distance d? Make sense? Now, any moment if I see the force, then per unit distance, because of the force that the spring will travel, that per unit distance, that energy will be forced into one. That energy will be forced into one. Consider it travel for now. I if this is the d distance, I am breaking into n part. Okay, one part is xi. The width of one part is xi, that is the ith division from origin, first, second, third, fourth, n will hit d. Okay, the ith part is xi. If ith part is xi, then when a spring is traveling this xi, the energy it is liberating, work done, is force fxi. Fxi, the force at xi into xi, that is the width. If I want to show the width, I can better write a delta xi, that will tell the width. Okay, xi looks like location, so delta xi. Fxi, I in ith section, what is the force into delta x, what is the width of the ith section. Now that I have to add for all, and I will get the work done. Work done in this section, work done in this section, work done in this section, work done in this section. If I add all, it will give the work done from 0 to d. Now it will become like summation I equal to 1 to n f, that is the function over xi. This is the force function over xi into delta xi, that gives that width. If I just write xi, people will consider one point. Delta xi, that is give a very width. Now I equal to 1 to n fxi delta xi, that will convert into, since it is summation of delta xi, it will be converted into integration. The integration of x from 0 to d fxi fx dx. Now fx is x, then x dx, x square by 2, d square by 2 is the work done. But here it will not work. Here I am saying the small arc length is r into I. R is function of theta. Sorry, the small arc length is r into theta I, where theta is the angle of the ith section, where this full theta I have divided from 0 to 2 pi into I section, into n section, where n tends to infinity. If I take ith section r, then it is r into theta. So I can say ith section length is r into theta I. Summation of I equal to 1 to n tends to infinity, r theta. Theta I can write delta theta, so that it will show me one gap rather than one point. Delta theta I. Now delta theta I, that is a summation, I can make it d theta. R d theta, theta 0 to 2 pi is the net parameter. But when r is not function of theta, if r is function of theta, then if I write f theta d theta and do the summation and I convert into f theta, if I write f, if r is function over theta, f theta I into delta theta I, that is the length of one arc. F function over theta I, in the ith section, what is the angle? F theta I at that moment, f theta I into delta theta I. Okay, if that is the case, because r is function over theta, theta means this theta is growing like this. At any moment, what is theta starts from 0, and at any moment, what is the theta? That way, radius is changing. Radius is function over theta. F theta in the ith section, what is the theta? Theta from the beginning. This is what I am saying. Or someone can just write f theta, whatever comes to mind. F theta I into delta theta. Delta theta is in the ith section. what is the delta theta? Now, if I do summation, it will give the whatever I want. That will be f theta I d theta from 0 to 2 pi. But f theta I d delta theta itself is wrong. Like force into displacement is the work done. Radius, if radius is function over theta and radius multiplied by delta theta will not give the parameter. If radius is varying between begin point of delta theta and end point of delta theta, if radius is varying, this is not so. Beginning only it is wrong. Then how I can find perimeter of a circle where radius is function over theta? That is a very big question. Very big question. Very delicate question. How I can find perimeter of a circle where I take a small section length and then I divide this full length into n parts, and then I take the length of one small section and then sum it for all the parts and then convert into integration, because integration is representation of multiplication of two items y into x, where y is function over x, it becomes y dx, or repeated delta x. If delta x is repeating, and then all delta x, if I add repeating and non-overlapping, that is the better way. They are, one delta x is independent of other delta x, means they are non-overlapping. If they are non-overlapping, delta are there, and it makes the full length, like I am talking 2 pi theta. Theta is now divided into many theta, okay, where one theta angle, many delta theta, many sections. If this is the x-axis and theta goes like this, then it comes back to the 2 pi. It makes it makes two it makes 2 pi angle. Theta is making 2 pi angle, means theta limit is 0 to 2 pi. If theta limit is 0 to 2 pi, then in that fashion, then I can divide theta into many sections. One section, another section, in n section, where one section, that is ith section, the theta gap is delta theta. Now I can say delta theta I, delta theta 1 plus delta theta 2 plus delta theta 3, delta theta n equal to 2 pi, where each are not overlapping on each other, but they may not be equal also, not required. Anyway, now how to find perimeter of a circle in form of repeated addition that also constitute delta theta 1 plus delta theta 2 plus delta theta n, where all are non-overlapping and their addition brings 2 pi. This is what the desired is. Then this can be, the summation can be converted into d theta. D theta integration from I equal to 1, I equal to 0. I'm sorry, integration of theta from 0 to 2 pi. So summation I equal to 1 to n, where n tends to infinity, delta theta I is d theta integration 0 to 2 pi, where n I equal to 1 to n tends to infinity, means the 2 pi section of theta I have broke into n parts, where n tends to infinity, so many parts. Okay, now let's find, we will now, but our solution is ties on the one particular section only, but we could not find the length of section as r theta. That's the mistake we did. If r is constant, r is not dependent upon theta, then r theta will give the small section length. Or if this angle is, if this small angle is delta theta, if this small angle is delta theta, then this arc is r delta theta. But okay, how I can find now? That is the question. Now we have demonstrated a little bit in the past section also. Consider this is x-axis and this is y-axis. Now if this is y-axis, this is x-axis and y-axis. Now from x-axis I am moving angle theta. If theta is moving, I'll come to a location, I freeze it. Okay, I come to a location, I freeze it. Then I move delta theta and I freeze it. What is this delta theta? Here, consider this from x-axis, this angle is theta. Okay, now I freeze this radius. Then I move the radius theta plus delta theta. This section, this angular section of this movement, this is from the x-axis I move theta angle. I freeze it, and after freezing it, I move this radius delta theta more. Now this angle from x-axis is theta plus delta theta. Now at theta and theta plus delta theta, there is a small section here. What is this arc length where radius can be dependent upon theta, whatever it is? If I want this arc length, if this arc is very small, I can consider this as a straight line. If this is a straight line, now consider here, if I bring a vertical line here on x-axis, this point is x. Now another point here when I move delta theta. Now this point is x plus delta x because of the movement into delta theta. Now I have 2 points. The arc, this arc position is x and this arc position is x plus delta x. Makes sense? This arc position y is y, then this arc position change in y I have seen. If I talk in y axis, then this arc position is y. If I move to another arc position change in delta theta, this arc position change I see in the y plus delta y or y minus delta y, whatever it is. Okay, so this position is x comma y and this position in x plus delta x comma y plus delta y. Okay, this proves that it forms a triangle here. Makes sense? Here, here, consider this is a straight line. This arc is a straight line because I have taken arc length as very small. If this is a straight line, if this is a straight line and I move like this, okay, then there is a triangle like this. From this point I am saying because we are at x comma y. X comma y, if I come down here, then this is x only. Okay, and in that fashion, if I move like this, and this is perpendicular, then like this is a small triangle. It makes a small triangle where the movement of x is delta x and movement of y is delta y. Delta y and delta x. Hope. Too much confusion, I believe. Okay, we'll try again. Okay, consider. Okay, this is the point, and then I move up. This point is x plus delta x. If I move up, then this length I see, this I make it bigger so that it will be more clear. Okay, the concept is consider this is a point here, and this point here touch here, and this point touch here. Okay, this is the point and it touch here. This is x plus delta x. Now I move delta theta and this point is x. So actually this is x and this height is y. This is x comma y. If this is x and this is y. Now if I move like this, okay, then this is x plus delta x. Okay, what is the length of this? Consider this is a straight line. This arc is a straight line. Because delta theta I move is very small. If delta theta is very small, I can take this as a straight line. If I take this as a straight line, what is the length of this line? This line length is the arc length. This is what we are interested in. What is the arc length when angle movement is delta theta? If I know that, then I will sum it for all. This is hypotenuse and this is delta x and this is delta y. I believe it is understood now. This is the begin point and this point is x comma y. I moved like this. Now this point is x plus delta x comma y plus delta y. This is the original point. Here it is x. X moved delta x. This is the original point. It is y. Y moved delta y. Vertical change is delta y. Horizontal change is delta x. In that fashion, this will form a triangle like this. This is delta x. This is delta y and this is the hypotenuse, that is the tangent at that point. This hypotenuse length is delta x square plus delta y square root. Makes sense? Now I know that for the ith section, if I divide it into I section, this is theta, that is 360 degree. If I divide into n section, then ith section arc length is the delta x whole square, delta x that corresponds to the ith section. Delta xi whole square plus delta yi whole square root. Now summation of I equal to 1 to n where n tends to infinity, square root of delta xi whole square plus delta y whole square is the net net circumference, and this holds true when r is varying with the theta also. If this is at angle theta, this is x-axis, and now radius is at angle theta. This is the radius. If I move delta theta, radius started shrinking, and after delta theta, this is the radius. This is the delta theta, and this radius shrink here. But still, this arc is so small, I can take a straight line. You take a straight line or you don't take a straight line, you cannot say this is r into theta, because r has to be constant, then only you will say it is r theta. But still, if radius is decreasing, this is delta x and this is delta y. If this will be hypotenuse only, that is delta x square plus delta y square root. So that is perfect. Even though r is varying with the theta, for the ith section delta theta movement, the arc length will be delta x whole square delta y whole square root. That is the hypotenuse. So what is the circumference now? The circumference is sigma I equal to 1 to n where n tends to infinity square root delta xi whole square plus delta xy whole square. Delta x belongs to ith section and delta y belongs to ith section. Okay, thank you very much. Is it what we were talking? Yes, this is what we were talking. Then how I can find the length? Now this is perfect case where delta x is getting added and delta y is getting added. Okay, in that fashion I can write delta x summation of I equal to 1 to n square root delta xi whole square plus delta y whole square, delta yi whole square. If I break this summation, it will become a square root of delta x first section whole square plus delta y first section whole square plus the square root of delta x for the second section, the section I am cutting here. This is x-axis, and this I made many sections till it is come back to 2 pi 360 degree. First section, second section, third section of this parameter, section by section. For the second section, like that, the last nth section is the square root of delta xn whole square plus delta yn whole square. If this addition is happening section by section, then each delta x is not overlapping another delta x, where delta x is going along x-axis and delta y is going along y-axis, and each delta x for one section of parameter, for one section of this parameter, if I come down, it will make delta x, delta xi. If this section of parameter is the ith breakup of this parameter, then for ith breakup, this delta x is a delta xi. For ith breakup, this delta y is delta yi. If this is a jth breakup, then if I come here, this is delta xj, and this is delta yj, like that. If I keep adding it, it is a fit case for square root of dx square plus dy square. Okay, and then I consider, but it should be only one. I can take variation in only one, because we are calculating the length. It cannot be dx dy. Okay, then it will become then I have to let it write like this. Then it will become a square root of dx whole square plus dy whole square. Okay, dx, where x is minus a to a, radius is minus a to a, because x will change from here to here. Theta concept is gone. Where y and x are related to each other, dy I will convert into dx only. Now dx from minus a to a, this will completely come like this. This repeated addition where delta y, what is y? For a circle, y equal to square root of a square minus x square. That will become dy equal to minus 2x by square root of a square minus x square dx. I'm sorry, minus x. Dy equal to square root of a square minus x square. Dy or dy by dx equal to minus x by square root of a square minus x square. Dy equal to minus x by square root of a square minus x square dx. Now I can fit it here. Dx whole square plus x square, that is dy, x square by a square minus x square dx. Okay, dx whole square. I'm really sorry. I'm really sorry. Okay, I will rephrase it. We started with the summation of I equal to, I am also little bit. These are not available in any of the book. That is the problem. This is our research. Now, summation of I equal to 1 to n, square root of delta xi whole square plus delta y whole square. This is what we found as the net repeated addition as far as circumference is concerned. If that is the case, then I can write it as square root of delta x first section plus delta y first section plus the square root of delta x first section plus second section plus delta y second section plus square root of delta x nth section square root of delta x nth section whole square plus delta y nth section whole square. This is the repeated addition of delta x when all delta x are not touching to each other. If this is the section I am taking on the parameter, all delta x, okay, parameter, then all delta, then someone will say if you come back, then it is overlap. This side if I take, then delta x is going like this here. But if you come back, let's take top part only. Bottom part is a repetition of that only. Let's take only top part, then it's all right. 0 to pi only. Now in that sense, x is from minus a to a. Now delta x is going like this. They are non-overlapping to each other. Similarly, y will be non-overlapping to each other. In that fashion, delta x, delta y, delta x, delta y, delta x, delta y, if they are, what I am trying to say is delta x1 plus delta x2 plus delta x3 plus delta x4 up to delta xn, if someone is saying, up to delta xn, if someone is saying, then it will exactly become 2a. 2a. N means I have divided up till here only, not full. Okay, because delta x will overlap in that fashion. So 0 to n section up till here only. If I do so, then this delta x1, delta x2, these are the delta. If I add from 1 to n, it will become 2a minus a to a of the circle. If that is the case, then it becomes like delta it will, then the summation it becomes like delta x1 plus delta x2 plus delta x3 delta xn equal to 2a. Okay, similarly delta y1 plus delta y2 plus it also, it delta y1, it will become a because I have taken top part only, but they will be non-overlapping to each other. What are you trying to say? What I am trying to say is summation of I equal to 1 to n, the square root of delta xi whole square plus delta yi whole square will not transform because it is a repeated addition. It will transform into integration, just integration mark, the square root of dx whole square plus dy whole square. Delta x will convert it into dx and delta y will be converted into dy. That's it. After that, I was just mesmerizing dx, dy, something like that. That's it. Okay. Now y equal to square root of a square minus x square. Dy by dx equal to minus x by square root of a square minus x square. Dy equal to minus x by square root of a square minus x square dx. Now if I change it, integration sign, square root of dx whole square plus x square dx whole square by a square minus x square. Dx I can take it out. Okay, dx square here also dx square. If I take it out in the square root, it will become dx. Dx I can keep outside. It becomes a square root of 1 plus x square by a square minus x square. Minus x square and x square gone. It becomes a by a square by square root of a square minus x square square root. A square I can keep outside. That is a. That is the radius of the circle. Constant. Now it becomes 1 by square root of a square minus x square dx. Makes sense? Dx. And then integration x is minus a to a. Someone can compute and it will give the perimeter. It is supposed to give the perimeter. I am not running it. Someone can try. What is 1 by a square root of a square minus x square dx? Sine inverse x by a. If it is minus a, the sine inverse minus 1. Sine inverse minus 1 means minus pi by 2. Okay, minus a to a. Sine inverse 1 minus Sine inverse minus 1. So sine inverse 1 is pi by 2 minus minus plus pi by 2. Pi. It will become pi. Pi into a. Pi a. That I calculated for top only. 2 pi a is the parameter. Anyway, we will proceed in the r cos theta. We have not taken into consideration if r is varying with cos theta. So what I need to do, we took in x and y only, and where y is function over x. But we forgotten that x is also function over r theta and y is also function over r theta. Dx I have to substitute with the r theta variation. Dy I have to substitute with the r theta variation. Then it will give the perimeter of a circle where radius is here. I'm sorry, the origin is here and it is r equal to cos theta that we are talking. What is the perimeter of circle where r equal to cos theta? Okay, we will see with the dx square plus dy square root. That fundamental because it covers a variation in radius also. Okay, please do not mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. Plus 91 is the India country code. 9483160610 is the telephone number.